my name is David Steele. I'm a product manager at Arcturus. Today I'm going to give you a quick demo and talk to you a little bit about speaker-independent speech recognition. We've implemented speaker-independent speech recognition as a voice control interface into our middleware, and this allows you to create fairly easily voice control devices. So those devices can be for a variety of applications, allows you to control external I/O or run system functions or tasks. Speech recognition over the last few years has become quite popular. We use it in our cars today to do things like control the climate or the temperature of the vehicle. We use it in our smartphones to change the music we're listening to, or perhaps call a friend. The thing that makes speaker-independent speech recognition so unique is the fact that it doesn't rely on the user to train the system, so that instead it relies on an acoustic model, and that acoustic model creates the user generalization. So the acoustic model that we use in our system is one of the most popular ones. It's called the WSJ1 acoustic model, and it's capable of supporting about 100,000 unique words. From those 100,000 unique words, we create a language model, which is a subset of that, and it's more specifically geared towards the application that we're using. So it's comprised of two parts. It's comprised of the dictionary of the words that we specifically want the system to recognize, and it's comprised of the vocabulary, the phrases that we want the system to recognize and action as well. So we have a white paper on speaker-independent speech recognition, which we'll include the link to at the end of this video, so you can refer to that for more information. It goes in depth as to how our whole system solution works, as well as speaker-independent speech recognition. But first, why don't I give you a quick demo, and then from there we'll jump into my laptop and we'll look at some of the web configuration and also the API that you can tie your application into. So from a hardware perspective, this board here that I have is the UC53017 EVM embedded voice module. It's a development kit that we sell that's pretty much off the shelf. It's connected back to our local network here, which is also connected to the internet. My laptop is connected to the same network, and I can use my laptop to get to the web page of this device to do some configuration. I've also got a serial console connected to my laptop that's just used for monitoring the system processes. I've got a microphone input and PC speaker outputs. The PC speakers are used to provide some audible feedback. There's some prompts that go along the way that let you know the status of the system. And then we've created this fairly simple hardware board here, which has a couple of relays on it that allow us to control these external LED lamps. So the demo works sort of in the same sort of way as a smartphone with a Bluetooth device would work, and there's a full demo setup and operation guide that's available from the support side as well. We'll put the link to that at the end of this video. What's going to happen is I'm going to press the button, and when I press the button, it's going to prompt that it's ready and it's listening to my voice. It's going to listen, it's going to then decode the speech, it's going to parse it, and it's going to try to execute the command that I'm giving it. So the first command I'm going to try is I'm going to tell it to enable this orange lamp or turn on this orange lamp. So let's give that a shot.
Ready.
Enable orange.
Done. Okay.
And as you can see, it turned on the orange lamp, and at the same time it was saying it was done listening to my voice and it was okay that it found a match. So I can turn it off in a similar sort of way as well.
Ready.
Disable orange.
Done. Okay.
And there you go, it's turned off the orange lamp. Now there are several other system commands that we provide access to, and of course you can extend this framework any way you like. For example, we have the ability to read back the IP address of the device.
Ready.
Say network address 0.
Done. Okay. Your IP address 192.168.154.1.
And as you can hear, it's reading back the IP address of the network device. Now, since this is a voice over IP system as well, I've already pre-configured a voice over IP account using the web user interface, and I've also already added myself to the phone book. So I've added my name and also my phone number, much like you would do in your smartphone. And what that does is it allows me to dial my phone by calling my name. Now, the cool thing about that is for applications like assisted living that I mentioned before, where someone might need to call for help or call for assistance, and so it can decode this fairly easily and then route that call to a destination where someone might be able to show up on scene to help them. So let me give that a shot.
Ready.
Call David Steele.
Done. Okay.
So, and then I can just reach around, and you can hear that it's starting to dial and call my phone, and it'll take a couple seconds, but there you go. And as you can see, it's calling my phone. I'm just going to hang that up. There we go. And that's disconnected from the call as well. So that basically is a very simple demo of some of the basic capabilities of our voice-controlled, our speaker-independent voice control middleware interface. Those are most of the functions you can use just through the web UI and basic configuration. Now we'll sort of jump into my laptop point of view, and we can see the web user interface for the configurable parameters, and we'll also go through the API for some of the prompts and the feedback, and show you how you can tie your application into that as well. So the page you're looking at right now is the login page to the web user interface for the UC53017. It comes as part of our middleware. I just want to go ahead and click on login, and then I'm going to log in using the username admin and the password admin. Now there's another demo that shows you how to configure and set up the UC53017 using the web interface. So I'm going to skip over most of the basic configuration settings and click on the VoIP tab page. As you can see, I've already got an account configured on this device. Now, what I wanted to show you here is over on the phone book tab. And as you can see, I've added my name, David Steele, and I've associated a telephone number with it. And I've added this to the phone book. Now, what that does when you submit this entry is it forces the language model in the speech recognition system to become regenerated, and it will add my name, David Steele, into it. So this means that from any time forward, when a command is issued that has the term David Steele, it will understand my name, and that means it can be parsed by the rest of the system, decoded from plain text, parsed by the rest of the system, and in this case, will be associated with the telephone number 5005. The other thing I wanted to show you is under the Advanced page and under the Miscellaneous Features tab, and this is the page that really lets us control the demo. So from this page, we can enable, turn on or off the command recognition demo. And the other feature we can add here, or change here, is control of the two external outputs that I had configured earlier. So if you recall, I had a blue and an orange LED lamp. And the commands that I was using to turn them on and turn them off were enable orange and disable orange, enable blue and disable blue. These could just as easily be other commands, such as lock door or unlock door or turn lamp on and turn lamp off. And that would allow you to connect with other external devices as well fairly easily. So that's how you can very simply run the basic setup and configuration for the demo that I showed you. What we'll do now is we'll just jump over to the serial console, and we can see some of the output from the system, including our middleware and the speech recognition tool itself. So what you're looking at right now is the login prompt to the shell console, which is running over the serial port for the UC53017, and it's going to give us a little bit more feedback from both the voice decode and also the middleware. So what I'm going to do, as I did in the earlier part of the demo, is I'm just going to reach over and I'm going to press SW2.
Ready.
And then I'm going to issue the command enable orange. As you can see, it switched into processing, and at the bottom of the, just after the decode, we can see in plain text the words enable orange. And it's gone ahead and illuminated the orange LED. And I can do the same thing again.
Ready.
Disable orange. And it will switch into processing, it will output some speech decode, and then it will disable the orange LED lamp. There are some other system commands as well that we have access to. For example, I can say
ready.
Show system log.
Done. Okay.
and this will output the contents of the system log. And this is a good example to demonstrate to you how you can extend this. You basically can voice control almost anything within the Linux framework itself. And there's some other commands as well that allow us to see what's going on with the language model that's built on the device.
Ready.
Show vocabulary.
Done. Okay.
And this shows us the vocabulary of the individual words that the system's designed to recognize. So we'll notice at the top of the list up here is the name David, and about 3/4 of the way down is the name Steele. And we know that those have been entered by me adding my name to the phone book and then regenerating the language model based on that. We can also issue the command
Ready.
show corpus.
Done. Okay.
And this shows you what's known as the sentence corpus, or the list of specific commands that the device is designed to identify as well. This helps to increase overall accuracy. Now we'll just give you a quick demo of placing the phone call as I did earlier on in this video.
Ready.
Call David Steele.
Done. Okay.
As we can see, it's decoded call David Steele. There's been a call that's gone back into our middleware system. It's come back with 5005, and now it's placing the call to my phone. And I'm just going to go ahead and just hang that up. And as you can see, the system's disconnected and gone back on hook. So as you can see, the majority of the speech system is interfaced to via plain text. What we've done is we've wrapped this along with a simple command parser into our middleware application framework. And we provide this application framework, we refer to it as AT command, in C-level source code. Hopefully I've been able to teach you a little bit more about speaker-independent speech recognition and also our voice control interface for our UC53017 and middleware system. If you do have any more questions, you can always refer to arcturusnetworks.com. We do have a white paper available, and there'll be a link at the end of this video that will direct you to that. And there's also the software and a demo setup guide, which are both available from the dedicated support site for the UC53017. Thanks again, and have a good day.